All right, so today we're talking about the Frizzlife PD600-TAM3, a tankless under-sink reverse osmosis system that's trying to check a lot of boxes. It's got a real-time TDS monitor and display, it's got an alkaline remineralization filter, and Frizzlife is claiming a 2-to-1 pure to drain ratio. So we all know most RO systems make clean water, but I wanted to know how well it actually works in the real world. So we did what we always do. We installed it, we measured the stuff that actually matters like flow rate, recovery rate, TDS creep, noise, install time, ongoing costs, etc. And then we sent before and after water samples to a certified lab to see what it removed and what it didn't. And I'll tell you right now, this one had some really strong performance, and it also had a couple of test results that surprised me. So if you're thinking about buying this system or just trying to figure out if tankless RO is worth it in general, this video is going to save you a ton of time, so let's jump right in. The Frizzlife PD600-TAM3 is a tankless RO system that sits under your sink and feeds a dedicated drinking water faucet. Instead of a big storage tank, it uses an internal pump to push water through the filters on demand. Then, after the RO process, it runs through an external remineralization filter that's designed to raise pH and add a little alkalinity back. Who's this for? If you want faster flow from the RO faucet than conventional tank-based systems, less clutter under the sink, and proactive alerts that tell you when it's time to change the filters, this is the type of system you'd want to look at. Up front, the PD600-TAM3 sits in the mid to upper range for tankless RO systems, and honestly, it's one of the more expensive Frizzlife options. But the ongoing cost is where things get pretty interesting, because once it's installed, it's actually pretty reasonable to maintain. Based on our filter cost per gallon calculation, dividing each filter's rated capacity by its cost and then adding them all together, the total ongoing cost came out to about 10 cents per gallon. And because this is a tankless system with a pump, it does use electricity, but in our testing, it was extremely low. We measured 0.003 kilowatt hours to produce 1 gallon in about 2 minutes and 17 seconds. Using the current average US electricity rate of 17.78 cents per kilowatt hour, and assuming a daily water usage for drinking and cooking of 3 gallons per day, that's roughly about 58 cents per year in electricity. So yeah, up front it's pricey, but the ongoing costs really aren't that bad. Now, here's how it works. There are 3 individual filter cartridges, a combined sediment pre-filter plus carbon block stage, then the RO membrane, and finally a separate external remineralization filter after the RO process. As far as features, this one has a real-time TDS display on the front of the unit. This is great for quick diagnostics. For example, if your tap water is 600-ish TDS, and then all of a sudden your RO water is showing as 200, you'll instantly know something is wrong. It has a filter life indicator that's timer-based and color-coded, plus it'll beep at you when it's time. And it's tankless, so it saves space under the sink. And one more safety type feature is that if it runs continuously for 30 minutes, it'll go into protection mode and auto shut off. Before I jump into the installation and performance analysis, let me explain our testing and data collection process. We tested the system in real-world conditions on one water source in Colorado with the contaminants that were already present in the water. We did not spike the water with extra contaminants on purpose, and this is a single test to see how it compares to the manufacturer's claims, not a long-term reliability study. And in addition to our standard lab testing, I've now gathered a lot more data than my previous reviews as well. So if all the data coming up is interesting and helpful for you, definitely give this video a like to let me know that I should keep testing RO systems like this. And of course, if you have any questions or feedback for me, I always love to hear from you in the comments. So this time, I tested and measured all kinds of important data points specific to tankless RO systems, including installation time and number of potential leak points, TDS creep after letting it sit idle overnight, actual flow rate when producing water on demand, its efficiency, which includes the pure to drain ratio, as well as recovery rate, automatic flush behavior, and how much extra water is wasted during this process, noise it makes and how loud it is, and that ongoing cost per gallon and energy usage I'd already discussed. And then we sent 2 water samples to the lab like we normally do. One sample from the kitchen faucet as the baseline, and one sample from the Frizzlife dedicated faucet after following flushing instructions and completing all the other hands-on testing and analysis for flow rate, wastewater, etc. We also tested chlorine on site because chlorine is volatile and you want to measure it immediately. Now, here's what you need to know about my experience installing the PD600 and how feasible I think it is for most folks at home to do it themselves. Frizzlife claims this system takes less than 30 minutes to install. Our install took about 90 minutes. Now, full transparency, under sink RO installs can vary a lot depending on your specific sink setup and whether or not you need to drill holes. In our case, we already had a countertop hole from a previous soap dispenser, and we used a disposal drain adapter that avoids drilling in the drain line, which essentially made 2 big steps of the install process a lot faster. So if you have a disposal in your sink and it has a dishwasher drain connection, I'd highly recommend using this drain adapter instead of drilling a hole in your sink drain. It has a universal push to connect fitting for both 1/4 and 3/8 inch RO drain lines and avoids permanently modifying your plumbing. I'll link it up for you in the description, so make sure to check it out. And this is my recommendation for any RO, not just specifically this one, because it makes the install just so much cleaner and easier. Now, even though I didn't have to do any drilling, there were still a few things that slowed the install process down. The 1/4 inch tubing isn't pre-cut or color-coded, so you're measuring and cutting your own runs. Not horrible, but it's slower and easier to mess up. Also, I highly recommend using a dedicated pipe cutter tool, not cutting the pipe like I initially did, since you need these cuts to be perfectly even. I'll link that up in the description as well. The gasket on the 3-way feed water valve can fall out easily during install. Again, not a huge deal breaker, but still, it's something I wanted to call out since I did notice it happening during my install. We counted 10 potential external leak points across fittings. Now, the system did not leak during our testing, but more connections generally means more opportunities for issues over time. After installation, we followed the manual's initial flush procedure and let it run with the faucet open for 20 minutes, which ended up using 8.87 gallons of water. So overall, it's definitely not the hardest install that I've ever done, but it's also not the simple 30-minute install that the marketing suggests either. Let's talk TDS Creep, because this is one of those things with RO systems, and especially tankless RO systems like this one, that nobody seems to talk about. TDS creep happens when an RO system sits idle. Pressure equalizes across the membrane, and the first bit of water you draw can have a higher TDS than the stable output once the system has been running. Here's how we tested it. We let the system sit idle for 10 hours overnight. Then the next morning, we took the TDS reading from the first draw. Then we ran the water for 2 minutes and took the TDS reading again at the lowest stable number. And what did we find? First draw TDS was 474 ppm. After it stabilized, 49 ppm with the remineralization filter, 40 ppm without the remineralization filter. So yes, this unit showed noticeable TDS creep. The good news is that it stabilizes quickly, so if it's been sitting unused for a while, I'd recommend just running the faucet for a few seconds before filling your glass. Now let's talk efficiency ratio, because I've been meaning to incorporate this into my analysis of RO systems for some time now. I've had a hunch that efficiency claims made by some of these manufacturers are overly optimistic and may not include automatic flushing, for example. Frizzlife claims a 2-to-1 pure to drain ratio, meaning for every 2 gallons of water purified, 1 goes down the drain. And as a quick refresher, or for anyone who doesn't know, water waste is an unavoidable part of how the RO process works. We measured efficiency by collecting wastewater directly from the drain line while the unit produced purified water. In our small draw test for 12 ounces of purified water, it produced 12 ounces of wastewater. That's a 1-to-1 ratio, meaning 50% recovery. Then we repeated the test with a larger draw. When we produced 64 ounces of purified water, we measured 42 ounces of wastewater. That's about 1.52 to 1, which is much closer to the 2-to-1 claim. So what do I think is causing the difference? Tankless RO systems have a less efficient startup phase. When the system has been sitting unused, pressure across the membrane isn't at optimal differential pressure, so more water goes down the drain until it stabilizes. A small draw captures mostly that inefficient window. A larger draw gives it time to settle into this normal operating mode. Additionally, there's the periodic automatic flushing that most tankless RO units are also programmed to do, which is intended to address the TDS creep phenomenon I already discussed. The unit flushes the membrane automatically when it powers on for 30 seconds, after 10 minutes of constant production for 15 seconds, after 10 minutes of cumulative production for 10 seconds, and in standby, 18 seconds every 6 hours. And this unit has a button that allows you to start and stop a flush cycle manually, which made this super easy to test. So we initiated a manual flush to simulate each of those automatic flush cycles and captured the amount of wastewater produced for each set time span. We measured in ounces and converted to gallons and found that a 15-second flush wastes 0.25 gallons, a 10-second flush wastes 0.17 gallons, and each standby flush wastes 0.3 gallons. And since the standby flush happens 4 times per day, you're looking at about 1.2 gallons going down the drain, even if you don't use the system at all. So the big takeaway is that the 2-to-1 pure to drain claim seems to be related to the RO production cycle alone. In real life, your total wastewater is a combination of the normal production drain water plus the automatic flush drain water. That doesn't mean it's bad. Like I said, RO has to waste water as part of the process. And for some additional perspective, even with the additional wastewater from the automatic flushing, this unit is still far more efficient than most conventional tank-based RO systems that waste 3 to 6 gallons just to produce 1. This unit has a rated production rate of 600 gallons per day, and with tankless RO systems, that GPD rating is really reflected as a faster flow from the dedicated faucet. We tested the flow rate by timing exactly how long it took to fill 12 ounces of water, using video footage so we could get the timing accurate down to the frame. The average fill time was 12.67 seconds for 12 ounces. That works out to about 0.44 gallons per minute, which is roughly 639 gallons per day when converted. So in our test, it actually performed a bit better than the 600 GPD claim. It has a faster flow, which is noticeable when filling your glass. Maintenance is one of the PD600-TAM3's strongest categories. Filter changes are simple: turn off the water and power, depressurize, twist out the old cartridges, twist in the new ones, and hit reset. Frizzlife says 3 seconds, which is a bit overzealous. The swap itself is fast, but after replacing the filters, you still have to do a flush process, which takes 10 minutes for the pre-filter or 20 minutes for the RO membrane. Still, compared to traditional under-sink RO systems with multiple canisters and tubing to disconnect, the maintenance is quite simple and straightforward. Again, cost-wise, we calculated about 10 cents per gallon in filter costs and negligible electricity cost, roughly 59 cents per year under average usage assumptions. So once you get past the upfront price, it's not expensive to keep running. At this point, based on our hands-on testing, here's what I really like about the PD600-TAM3. It delivers fast flow from a dedicated faucet, which is one of the main reasons people go tankless in the first place. It's also easy to maintain with simple cartridge swaps and a clear filter life indicator. Efficiency-wise, once it stabilizes, it can deliver a decent recovery rate, even with the additional wastewater from the automatic flushes factored in. And the remineralization filter meaningfully affects pH and mineral content in the filtered water, which I'll show you with the data in the lab test section coming up. Now, for a few downsides, first and foremost, it's not performance certified for contaminant reduction, despite misleading marketing info on the product page that claims it is certified. And for a system in this price range, I don't love that. Certifications matter because they not only prove it will perform as the manufacturer claims, but they also include material safety testing and manufacturing audits. Second, the upfront cost is quite pricey. Third is build quality. Specifically, the 1/4-inch quick connect components felt noticeably cheaper and flimsier than some of the other RO systems we've tested. And fourth, we had a couple of weird contaminant reduction results detected by the lab. So now let's talk about our lab testing. We tested our water before and after the PD600-TAM3 using TAPScore advanced city water test kits. And when we interpret the results, we like to compare against health protective benchmarks, the HGLs, rather than just the more lenient, legally enforceable MCLs. In our baseline sample, we detected 16 contaminants with possible health effects, including disinfection byproducts, fluoride, uranium, nitrate, and a bunch of metals. And 5 of those contaminants exceeded health guideline levels, including all 3 disinfection byproducts, dibromochloromethane, bromodichloromethane, and bromoform, uranium, and fluoride. After filtration, the PD600-TAM3 did what you'd expect from RO. It completely reduced to below the reporting limit all of the disinfection byproducts, manganese, molybdenum, selenium, uranium, and vanadium. Additionally, it reduced copper by 98.8%, barium by 96.6%, sulfate by 95.9%, fluoride by 95.8%, strontium by 92.5%, and total chromium by 90.7%. There were 2 contaminants that were not reduced by as much as I'd expect normally from RO. Nitrate, which was only reduced by 50% from 1.4 ppm down to 0.7 ppm, which was a bit surprising since RO is normally one of the recommended treatment methods for nitrate. And boron, which was reduced by just 38.8% from 0.487 ppm down to 0.298 ppm. That one is less surprising depending on the water chemistry, which I'll explain in just a second. So what do I think could be going on? For nitrate, the honest answer is that I don't know for sure based on this one test. One theory is that nitrate could be re-entering the purified water somewhere downstream, possibly the remineralization filter, but nitrate isn't something we typically see in remin media, so again, it's just a theory. The cooler temperature of the feed water at 60.9 degrees could also have an impact on the rejection rate of nitrate by the RO membrane. For boron, there's a more established explanation. RO membranes tend to reduce boron more effectively at higher pH, often above 9. Our feed water was around 7.4. Combined with the cooler feed water temperature, a lower boron reduction is plausible. Now let's talk about the TAM3 part of the name, the alkaline remineralization filter, and whether it's actually doing anything measurable and what mineral concentrations looked like post-filtration. In our testing, feed water pH was 7.4, filtered water with remineralization measured 8.1, filtered water without remineralization measured 6.6. That's a really clean way to prove the remin filter is doing what it's supposed to do. RO water often comes out slightly acidic because you remove minerals and alkalinity. As you can see, this remin filter pushes it back up into a more alkaline range. Now, it's important to explain that remineralization filters don't restore minerals to what's naturally occurring in water. They can raise pH and add a bit of alkalinity, but RO still strips minerals overall, and what's added back by the remin filter is often much less than the raw water. For example, our lab testing showed that potassium was completely reduced to below the reporting limit. Magnesium was reduced by 95.8%, sodium by 95.2%, and calcium by 86.2%. So this tells me that the TAM3 filter is mostly adding calcium back. It's since we saw a lower percent reduction of that compared to the unfiltered water. All right, so here's how the PD600-TAM3 scored in our scoring system, top level categories, and why it earned an 8.94 overall. It scored a 9 for contaminant reduction, strong overall reductions in the lab, but held back by lack of performance certification. Design got an 8, great tankless footprint and useful tech features like the TDS display, but component quality felt a bit cheaper than some competitors. Certification for lead-free design to NSF-ANSI 372 through IATMO. It got a perfect 10 in the maintenance category. Easy cartridge swaps, clear filter life tracking, and low filter replacement cost. Filtration rate also got a perfect 10. Fast flow in our testing, about 0.44 gallons per minute, which is excellent for under sink RO. Setup was on the lower end, coming in at 7. Not as difficult as others, but our install time was 90 minutes, tubing wasn't color coded, and installing any under sink RO is a more complex process than others, especially if you have to drill holes. Frizzlife got an 8.2 in the company category. Warranty is 1 year with a free extended option to 1.5 years if you register. Shipping is free over $25 in the US, but they don't ship to some outlying areas. Returns are 30 days, but only for unused products in original packaging, which isn't a true test it out money back guarantee like we see offered by other brands. Now, who would I recommend this for, and who should skip it? What do I see as the deal breakers? This is a solid fit if you want tankless RO with fast faucet flow, easy maintenance, and low ongoing cost, and you like the idea of remineralization. Who's it not for? Most importantly, if you want a system certified for its performance claims, there are better options out there. Additionally, if you don't own your home and can't make permanent under sink alterations to your plumbing, I'd recommend looking at a countertop RO instead. So at the end of the day, the Frizzlife PD600-TAM3 is a strong performing tankless RO in a lot of the ways people actually care about. It's got fast flow, simple maintenance, low cost to operate, and a remineralization filter that measurably changes pH and adds calcium back. If you want to see the full test data and lab results, I'll link everything in the description where it's published on my website. And if you want to see how other undersink RO systems performed in my testing, stick around and watch the next video coming up right now. Click or tap to keep watching.